One of the tools that my lab uses to look for early markers of disease is to look for antibodies that respond to proteins displayed in those diseases. Cancers produce proteins that get displayed to the immune system, and our immune systems respond to that. And so in a sense, our own immune systems act as sentinels that identify the presence of disease proteins, and we can pick those antibodies up and use them to diagnose the disease. Now, historically, the way my lab has done this is we've printed genes on a chip, a little microscopic chip, and then express those genes into proteins. What's changed for us in a big way in the last year is this development of this human lysate from HeLa cells from Thermo Fisher, which completely has been a game changer for us. We're making probably 10 times more protein than we've ever made before. And I think from my perspective as a chief investigator in a lab, what's really been powerful is that every batch of that product has been the same. Historically, the cell-free extracts that we've been getting vary. Each time you get a different batch, it's behaved a little bit differently, and so we've had to adjust our methods, or we couldn't compare current results to old results. But this new product is the same every time we get it, and so it's allowed us to do a lot more experiments, be more reliant on those experiments, and actually have better signals from those experiments. What we're doing now is we're using this extract, the human hIVT system, to produce these proteins on our protein chips. And then we're taking patient samples and probing those chips to see if the patient samples identify any of these proteins. We make those proteins, we probe it with serum from patients, and we look to see if we can identify responses that correlate with the disease. And so we're doing that in breast cancer, we're doing that in arthritis, we're doing that in diabetes. We're now beginning to do a project in lung cancer, so we have a variety of different human diseases, all of which we're using this lysate to produce the proteins for. If we can identify markers that truly correlate and are predictive of response to therapy or early diagnosis, then we can turn these into actual biomarkers that can be then used clinically. And I'm a physician as well as a scientist. And obviously it's the patient care and seeing people that make you realize that we really do need to be better at what we do. We've certainly made inroads in cancer, there's no doubt about it. Patients are still dying from cancer at an enormous rate, and we still don't understand the disease as well as we need to. And so what drives me every day is thinking that, if we can find these new diagnostics, if we can get them out into the clinics where people can then use them to detect the disease early, we can make a difference in people's lives. We can actually get them treated before the disease really takes hold.